Hello and welcome to another video. In our previous video, we solved the lead code problem on Fibonacci sequences. We solved it using two different methods. Be sure to check it, link is in the description. However, today I want to go in depth into two different methods. The first was the brute force method, where we just pretty much typed in the Fibonacci sequence formula and it looks something like this. But in this case, I'm going to go ahead and run it and show you why this is not as good or as efficient as a method as using dynamic programming or memoization. Say we decided we wanted, for smaller numbers like say 5, Fibonacci of 5, the brute force method works fine. However, say we wanted Fibonacci of 50, okay? This is gonna take a while and I'm gonna show you guys why. So I'm gonna go ahead and run this. And at the same time while I run this, I'll go ahead and type up the dynamic programming version of this code. So it's really similar, to be honest. I'm gonna start off by copying the brute force method, and then I'm gonna create an empty dictionary. This dictionary is going to keep track of items we've already seen. And the first step after creating this is saying if the number n is in our memo dictionary, all we have to do is return return memo of n. Okay, it's that simple. However, if it's not in our memo dictionary, okay, what we want to do is we want to put him in there. So memo of n is going to be equal to the recursive call of the function. We have to say fib2. I'm going to go ahead and call this function fib2 so we know it's different than this one. I'm going to call it here fib2. Okay, and then we return memo of n. Okay, so like I said, pretty similar. Only difference is this dictionary created. I'm going to go ahead and run this. Boom. We see the dynamic programming method is done while the Fibonacci method is still going on. And we're going to look into this and see why this actually works better. So as always, we're going to visualize the code just to see what's going on. But before we do that, I kind of want to explain to you guys what's going on a piece of paper. So for example, in the case of dynamic programming, or in the case of Fibonacci in general, say we decided we wanted the Fibonacci of 5, f of 5. Okay, and just like the formula says, f of 5 is going to be f of 5 is going to have to calculate two different things. F of 4, because that's n minus 1, and f of 3, because that's n minus 2. Okay, just like the formula says right here. Then next, f of 4 is going to do the same thing, split into two branches, f of 3 and f of 2. Okay, f of 3 is going to do the same thing on this end. Okay, f of 2, f of 1, which is where we stop, because we know f of 1 is going to return 1, f of 0 is going to return 0, so we don't have to, so f of 2 is going to split into f of 1 and f of 0. Okay, the same thing on this end. This is f of 2. F of 2 is going to split into f of 1 and f of 0. And on this end, f of 3 is going to split into f of 2, f of 1. F of 2 is going to split into f of 1 and f of 0. Now, with the memoization or dynamic programming method, what we're doing is we created a dictionary called memo. And as we iterate through this Fibonacci sequence, since this has a tree structure, we're going to start from the bottom. We know f of 1 equals 1. So as soon as we do it, we store a value of key value per, where key is the number n, and the value is the Fibonacci sequence. Okay, so f of 0, we do the same thing. Actually, we do f of 0 first. So it's 0 and 1. Okay, 1 and 1, f of 1. Okay, then we have those two. Then we go up here because it's a recursive method, so we keep popping out of the stack. We go upwards this way, and then we calculate f of 2, and we know f of 2 is just f of 1 plus f of 0. So in that case, we store in the dictionary as soon as we calculate him 2, and his value is 1 plus 1 is 2. Okay, I'm sorry, 0. This is 0. F of 0 is 0, not 1. And this is 1. Okay, cool. Then again, we see this guy here, but we don't have to calculate him because of this if statement we have right here. This if statement right here, we don't have to calculate him a second time. All we do is look in the dictionary and know we have 1 in there and pick this guy as 1. Okay, and then we just have to add these 2. We calculate f of 3. F of 3 equals 2. Then we go ahead and store him in the dictionary, 3 and 2. Okay, so at this point we go back up we go to the second leg. Okay, obviously there's guy's bottom of the stock, so we go to f of 1. F of 1 we don't have to calculate him, we've seen him before, he's 1. F of 0 we don't have to calculate him, we've seen him before, he's 0. Okay, we move upwards. Again, keep in mind that this from f of 2 downward, we've seen him before, so we don't have to do any of this calculation. We just go in the dictionary and pick out the value 1 and pass him upward. So now we have 1 plus 2, because f of 3 is 2, f of 2 is 1, which gives us f of 4 is 3. Of 4 is 3. Once we calculate f of 4, we store him in the dictionary too. Okay, and then 4 is just 3. I think my math is wrong, but however, once we calculate f of 4 is going to give us 3. We store that in the dictionary, and then we keep going upward, and we see this whole left leg of this sequence, we don't have to calculate him the second time. Why? Because we have the value right here, f of 3. All we have to do is look in the dictionary and pick him out. But however, for the brute force method, we always have to calculate each leg. That is why it takes so long. As always, we like to visualize our code, so I'm just gonna go ahead and copy the dynamic programming method. Okay, let's run through it and see what's going on. So I'm just gonna go through it fast. Okay, we initialize our function here. Okay, then we initialize n equals 50, and then we pass him into, actually I'm gonna edit this, I'm gonna do it for 5, not 50, because 50 is just gonna take forever. Okay, boom, let's go. Okay, we initialize n equals 5. Memo is just an empty dictionary. We pass memo into this function scope, which is the same memo variable. Well, not the same technically, it's a shadow variable, but they're both pointing towards an empty dictionary memory. Okay, so the first line says, keep in mind the green is the line that just executed and the red is the line that's going to execute next. First line says, if n is the memo, in this case memo is an empty dictionary, nothing is in, so we're just going to skip this if loop. So next we're going to check if n is less than 2. In this case here, n is not less than 2, I'm sorry, in this case n is 5, okay? So he's not less than 2, so we're going to go into the else block. So in our else block, we're going to calculate memo and initialize him. So memo is still an empty dictionary. Once this green executes, we're going to calculate him. We can't calculate him directly because it's recursive, so we have to call these two guys in the stack. So think of the stack as a list of functions just piling one on top of each other. So we keep going down the stack, and as we keep going, we keep calling the functions. As you can see, these extra functions here, fib2, 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 they're just the stack, adding onto the stack. So we keep calling the functions recursively till we get to a point where we're ready to start popping out of the functions, and then we start populating the dictionary. So you see this first value 2 and 1 has been populated. We never have to calculate the fib of 2 anymore because we can just get him from this dictionary, and on and on and on. Keep populating our dictionary till we have a full dictionary, and now we can calculate f of 5 because Fibonacci of 5 is just Fibonacci of 4 plus Fibonacci of 3, which is just 5. So that's for the video, guys. I hope it was helpful. Be sure to tune in every day. We have a video like this. Thank you.